Now we shall see the types of cryptography systems based on the type of input mechanism of the message or input data. The major types are stream-based ciphers and block ciphers. Stream ciphers take the data input in the form of a stream and mix the key stream in the plain text to produce relevant ciphertext. Block ciphers, on the other hand, accept data input in the form of blocks instead of data streams. Stream ciphers are fast and easy to implement in hardware and thus are good for real-time services. Block ciphers are stronger but slower and often implemented in software. Now just a brief introduction to the different types of encryption systems. The encryption systems majorly used in today's crypto systems comprise of substitution ciphers, transposition ciphers, monoalphabetic ciphers, polyalphabetic ciphers, modular mathematics, and one-time pads. These types basically describe the patterns of changing the plain text to ciphertext, from a substitution cipher using letter replacement to transposition ciphers, which include word jumbles while rearranging or reordering letters within the message, or monoalphabetic or polyalphabetic ciphers where single or group of letters are substituted for plain text to ciphertext. Also mentioned here are one-time pads, which are randomly generated keys used to ensure a high degree of entropy in the encryption system. Now we shall discuss some very basic methods used in cryptography. Cryptographic algorithms generally fall into one of the two categories or are a combination of both. The types of methods used in cryptography are symmetric, asymmetric, and hybrid techniques. The overview of such methods is fairly simple, with symmetric cryptography being the use of same key for encryption as well as decryption. The major issue that arises here is the safe distribution of the key to the communicating entities. In asymmetric cryptography, a key pair is used for encryption and decryption. The catch here is that the keys are mathematically related, and the most common example is public key encryption schemes where the key pair contains a public and a private key. The public key is used for encryption while the private key is used for decryption. For hybrid approach, it combines strength of both methods, utilizing asymmetric approach for symmetric key distribution, the key being named as a session key, and the data encryption implemented in symmetric mode. Now, while symmetric encryption is fast, it offers only confidentiality and needs a secure channel for key distribution. Asymmetric cryptography is relatively slower and complex and provides authentication and non-repudiation. Moving on, we shall now see the concept of digital signatures. As the name suggests, it is a cryptographic technique offering services akin to that of handwritten signatures. It is ideally supposed to be verifiable and non-forgeable. The goal is similar to that of a MAC, that is message authentication code, except that it uses public key cryptography. The diagram here illustrates the concept of how a digital signature works. For the message M shown here, Bob encrypts the message with his own private key, which is known as the process of signing. This signing is necessary to provide non-repudiation service to the message or data. Another illustration of the said process is when the digital signature is in the form of an encrypted message digest. In this diagram, Bob first creates a hash of the message and then de-encrypts it with his private key to create the digital signature. For verification of the signature, Alice creates a separate hash of the same message and on the other hand decrypts the message digest using Bob's public key. It then compares both the values. If they turn out to be equal, it means that the signature is valid and verified. The process states that the verification process is done by applying the public key of the owner, and in the previous example, Alice verifies that only Bob signed the message M. For proving the same, she can take the message M and signature KBM to court and prove that Bob was the one who signed the message or data.